There is this one bird also known as Betelgeuse in our skies. It is a red giant star, and if you were to place it in the same location as the Sun, it would extend well beyond the orbit of Jupiter. It is gigantic, extremely unstable, and on the verge of exploding. Get ready for a cosmic catastrophe on a scale that has never been seen before. Astronomers have discovered something profoundly alarming about this enormous object in space. By utilizing the James Webb Space Telescope, a well-known scientist by the name of Brian Cox has issued a very serious warning. The red giant star, which is located on the border of our galaxy, is sending out frightening indicators through space. The topic that keeps coming up is whether or not we are about to witness a supernova explosion that will be so massive it would alter the night sky for all time. Let's jump right in and explore the grandeur of the universe. Stars are born, live, and die in amazing ways. A recent star has caught the attention and worry of both astronomers and regular people. This is Betelgeuse, a red supergiant star that stands out in the constellation Orion. It is very big and very old. Its unique reddish color and changing brightness have long been interesting, but recent events have made people even more curious about this cosmic giant. As we learn more about Betelgeuse, we are on the verge of a potentially extremely important event in its history. But what might these changes in Betelgeuse mean? Are we seeing the start of a cosmic show on an unimaginably huge scale? Betelgeuse is a stellar giant. It is about 764 times bigger than our Sun. It is so huge that it's hard for humans to understand. Imagine a star that immense. Not only does this enormous size demonstrate how remarkable the star is in terms of its physical characteristics, but it also reflects the stage of its life cycle that it is currently in. As a red supergiant, Betelgeuse is in the process of expanding and cooling during this phase, which occurs after it has transformed hydrogen into helium in its core. What about the age of the star? Despite the fact that it is believed to be between 8 and 8.5 million years old, relatively young in terms of human years but very old in terms of stellar lives, it has undergone a dramatic transformation over millions of years, transitioning from a hot blue star to the red giant that we see today. It is now in its final stage as a red supergiant. Stars like Betelgeuse undergo significant changes over the course of their lives due to the constant pressures of nuclear fusion and gravity. In addition, the distinctive reddish color of this stage of Betelgeuse sets it apart from others. The fact that its surface is not as hot as the surfaces of other stars, like our Sun, is the source of its red tint. The surface of the Sun is around 5,500 Kelvin, while the surface of Betelgeuse is roughly 3,500 Kelvin. Chilly in comparison, Betelgeuse can emit light at wavelengths that make it look red. This hue isn't just a look. It tells us something about the star's physical state and the processes occurring inside its massive gaseous volume. The fact that Betelgeuse's color has varied over time adds to its mystique. Writings from the Roman and Chinese eras say that Betelgeuse was yellow about 2,000 years ago. In the 9th century, Arabic experts were the first to say that it was red. This change in color over the course of human history is not just a small fact in the history of science. It also shows how the star evolved. Another interesting thing about Betelgeuse is that its brightness changes over time. It is a semi-regular variable star, which means that its brightness goes up and down on a regular basis. This dance of brightness has fascinated scientists and skywatchers for hundreds of years. Usually, Betelgeuse goes through a 400-day cycle and a longer cycle that lasts for 5 years. As early as 1836, Sir John Herschel wrote about these cycles, and Aboriginal folk histories may go back even further. But what really makes Betelgeuse mysterious is not just how its brightness changes, but also how uneven it is. Unlike many stars that dim and brighten in a predictable way, Betelgeuse sometimes deviates from this pattern. This suggests that complicated and less well-understood processes are happening inside its huge form. Recently, astronomers and stargazers all over the world were shocked to see Betelgeuse's appearance change dramatically and unexpectedly. This is now known as the Great Dimming. In late 2019, the red supergiant Betelgeuse, which is one of the brightest stars in the night sky and a prominent feature of the constellation Orion, started to dim in a mysterious way. The star was getting so dim that it started losing its light at a rate of 0.01 magnitude per day on average. In February 2020, it was at its dimmest. Betelgeuse, which can usually be seen with the naked eye even in places with a lot of light pollution, got much fainter, and even casual viewers could see the difference. The time paradox, on the other hand, makes it hard to keep an eye on what Betelgeuse is doing because light takes so long to get to us. When we look at a star like Betelgeuse, we don't see it as it is now, but as it was in the past. For Betelgeuse, the light we see today left the star almost 700 years ago because it is about 725 light-years away. This time lag makes it hard to predict and monitor quick changes in its behavior. The Betelgeuse dimming event was a reminder of how hard it is to observe the sky in real time and how little we know about the big, strange worlds of space and time that they create. Andrea Dupree, Deputy Director of the Center for Astrophysics at Harvard and Smithsonian, and her team closely watched the events of Betelgeuse's celestial drama as part of a 3-year study to track changes in its outer atmosphere. They used Hubble to look at the huge star. These observations gave a new look into how a variable star like Betelgeuse works. Variable stars regularly get bigger and smaller, which causes changes in how bright they are. Researchers were able to look into the layers above the star's surface, which were heated in part by the star's swirling convection cells, thanks to Hubble's sensitivity to ultraviolet light. Additional examination of the Hubble spectra, which were obtained at different dates in 2019 and 2020, helped discover how fast things were moving in the upper atmosphere of Betelgeuse. The spectra were largely made up of magnesium-2 lines, which show what the star's atmosphere is like. The research showed that items were moving from the star's surface into its atmosphere at roughly 200,000 miles per hour. This hot, dense material ultimately reaches millions of miles distant from Betelgeuse. It was the start of the dust cloud that made the star less brilliant. During the 3 months of the outburst, Dupree and her team thought that about twice as much material as usual from Betelgeuse's southern hemisphere was lost. While all stars lose mass over time, Betelgeuse's loss was especially noticeable because it happened at a much faster rate than the Sun's. Astronomers talked about whether this event could be a sign of a supernova explosion because of how big this mass release was and how dim it became afterward. Being only about 725 light-years away from Earth, Betelgeuse adds to the mystery because any explosion like this would be visible from Earth and give people a rare chance to see a supernova up close. But the question still stands. What does this dimming mean for Betelgeuse's future? Is it a sign that a supernova is about to happen? Or is it just a one-time event in the star's long and complicated life? Several ideas have been put forward to explain this quick change. One popular theory suggested that it was a stage in the process of a supernova explosion. This idea caught on because most people think that Betelgeuse is almost done with its life. Another common idea is that dust, maybe from the star itself, is blocking our view. It is known that Betelgeuse and other red supergiants lose material. It was thought that this material could build up into a dust cloud thick enough to block our view of the star's light. A third concept looked at how changes in the star's photosphere, the visible layer on the outer part, might have an effect on how brilliant it appeared. This puzzle was answered by employing a variety of different observational methods and in-depth analysis. Spectroscopic studies showed that Betelgeuse's effective temperature plummeted. This shows that the star may be fading because of a big dark area on its surface. The fact that Betelgeuse's temperature dropped by at least 170 Kelvin around the time of the dimming supported this concept. This showed that there were big changes on the star's surface. In the end, the Hubble Space Telescope, which is humankind's watchdog in space, helped us figure out what was going on with this strange event. Hubble's view showed that the dimming of Betelgeuse was probably due to a large amount of hot matter being thrown into space. This matter created a cloud of dust that covered up some of the star's surface, which meant that less light from Betelgeuse reached us. It was thought that the dust cloud was made of very hot plasma that erupted from a big convection cell on the star's surface and moved through its hot atmosphere to the cooler layers on the outside. It formed dust grains as it cooled, creating a cloud that obscured light from approximately a quarter of the star's surface. Hubble's images indicated that after this outburst, a big, dense, hot dust cloud had formed. Although this dust cloud may have dimmed the star for a while, it is not expected to last forever. Researchers believe that Betelgeuse could soon regain its former brightness, so the mystery surrounding its variable behavior may not have been solved. Many experts expect that Betelgeuse will one day go supernova. there is evidence that shows Betelgeuse is running out of fuel. There are still uncertainties, but the scientific consensus is that it will eventually explode in a beautiful cosmic event. When will this happen? This is another mystery. Estimates have ranged from 100,000 years to only a few decades. It is not really clear when we will see this magnificent explosion. When Betelgeuse explodes, the light will be so bright that it will be visible during the day. If this occurs, it could change the night sky forever. A supernova explosion would result in a brilliant burst of light, making it brighter than any other star in the night sky. This momentous cosmic event would leave an indelible mark on human history, as people worldwide would gaze up at the sky, witnessing the death of a star that has fascinated humanity for millennia. As we keep an eye on Betelgeuse, it serves as a powerful reminder of the dynamic and ever-changing nature of the universe. And who knows, perhaps the day of the explosion is nearer than we think. Betelgeuse, also known as Betelgeuse, has captivated astronomers and stargazers alike for centuries. Its unique properties offer insights not only into the life cycle of stars, but also into the fundamental processes governing stellar evolution. As a red supergiant, Betelgeuse is nearing the end of its life, entering a phase marked by complex internal dynamics and atmospheric changes. One remarkable aspect of Betelgeuse is its location within the constellation Orion. This prominent star has been part of human culture for millennia, appearing in various mythologies and artworks. Its vibrant hue and conspicuous position make it an essential navigational aid in the night sky, often serving as a point of reference for other celestial objects. When it comes to stellar size, Betelgeuse is astonishing. If it were placed in the center of our solar system, its outer layers would extend past Mars, engulfing the orbits of several planets. This immense size leads to significant gravitational forces at play, impacting the star's structural integrity. As it exhausts its nuclear fuel, Betelgeuse undergoes dramatic changes that can influence its surrounding environment. The variability in brightness of Betelgeuse presents an exciting puzzle for scientists. These fluctuations provide a window into the star's internal activity, revealing how it generates energy and ejects material into space. The expulsion of stellar material is not merely a passive event. It plays a crucial role in enriching the interstellar medium with elements forged in the heart of the star. These elements eventually contribute to the formation of new stars, planets, and even life. Recent studies suggest that the processes leading to Betelgeuse's dimming might also be linked to its magnetic fields. As with the Sun, magnetic activity can cause sunspots or similar phenomena, impacting how light is emitted from the star's surface. This magnetic influence adds another layer of complexity to our understanding of stellar behavior. The supernova event that Betelgeuse is anticipated to produce will be a significant astronomical occurrence. A supernova is a cataclysmic explosion marking the end of a star's life cycle. This explosion will not only illuminate the sky but will also release a vast amount of energy, potentially influencing nearby celestial bodies. Interestingly, while many stars can be born and die without ever being observed from Earth, Betelgeuse's proximity, about 725 light-years away, makes it a prime candidate for observation. Scientists are keenly aware that they may witness this cosmic event in their lifetimes, leading to speculation about its potential impact on Earth's night sky. After the explosion, the remnants of Betelgeuse could form a neutron star or a black hole, depending on its remaining mass. The aftermath of such a stellar death is equally fascinating, as it leads to the formation of new celestial bodies. The gas and dust expelled during the supernova contribute to the cosmic cycle of matter, highlighting the interconnectedness of all elements in the universe. Betelgeuse's life and impending death serve as a vivid reminder of the dynamic nature of the cosmos. The ongoing research surrounding this star not only enhances our understanding of stellar evolution, but also ignites curiosity about the universe's mysteries. As telescopes become increasingly advanced, we can expect new discoveries that will deepen our knowledge of such phenomena.